we have a formula at the very top of the backside that is going to help us be able to take a shortcut to finding a given term of an arithmetic sequence. So in other words, our learning goal today does say, I can find a given term. I had you find the 20th of the first one, that's the given term. I had you find the 50th of the second one. So I can find a given term of an arithmetic sequence. Well, this crazy formula, I want you to put a box around it up here. That will help us take a shortcut. And once we understand what all of that means, you're going to be like, oh, that is so much quicker than what I was doing. Okay? So it starts out with a sub n. That's how we say it. A sub n. I'm looking at that part right there. That means any term. In other words, if in the first one, when I wanted you to find the 20th term, I would replace the n with the 20, and I would say a sub 20. We're looking for the 20th term, a sub 20. That will be equal to, if you can't tell that's an equal sign, make it into 1. That will be equal to a sub 1. A sub 1 meaning you got to start somewhere. So what's the first term of this sequence? Add to that this multiplication. Remember Blake and Adam were talking about doing some multiplying. Add to that n minus 1. Notice it's in parentheses. N, remember, is the term number. And so we would put it, like for that first problem, we would put a 20 there. 20 minus 1. What is 20 minus 1? 19. And then we would take that times the d. Remember, d is our what? What do we call that? D is common difference. What was the common difference for the first arithmetic sequence? In your notebooks, what was the d? Minus 2, negative 2. So we would take our 19 times the negative 2. Let's try that right now. Would you do this with me on your calculators, please? Let's take 19, because 20 take away 1 is 19. What's 19 times negative 2? Do that first. What's 19 times negative 2? Negative 38, which happened to be somebody's answer in here, didn't it? I feel like? Maybe not. Okay, I thought that was in our list. And then, but we have to go back and add the first term to it. So the first term of that sequence was what, wasn't it? 4? 4, yeah. So go, now add 4 to that. So you've taken 19 times negative 2, and now you're going to add 4 to that. What did you get? Negative 34. Isn't that the answer we said it was? Okay, let's try it with our second one. What would our n be in the second one? What's the given term number I wanted you to find? What's the n? 50. So we're going to put 50, and we're going to take 1 away from it. What's that? What's 50 take away 1? 49. What was our d value in that sequence? Plus 5, or 5. So when your calculators right now, would you take 49 times 5? And go back and add the first term of the sequence. What was the first term of that sequence? 1. So add 1 to it. And what do you get? 246, the answer that we said it would be. Isn't that a lot faster? So here's what happens. I want you to kind of look over here at the board with me. We start at a term, and we add to get the second term. So we've done it 1 time, but we have 2 terms, haven't we? We add it again. Now we have a third term. We've done it twice, but we have 3 terms now. So that's why we have to, we start with the first term. We have to subtract 1 from what do we want to find. We have to multiply by that number we keep adding, and we're going to have the term that we want in the sequence. So let's look at this one. Find the 50th term of this arithmetic sequence. The first term is 5. The common difference is negative 1.2. They're doing it right there. First, write the rule. So when they ask you to write the rule today, here's what you're going to do. You're going to take that formula that we just boxed at the top of the page, and you're going to substitute in the first term and the common difference. So in other words, you're going to say, no matter what term you want to find in this one, here's what it starts with, and here's what this is what my common difference is. And then, once we determine what which term we want to find, then we're going to substitute that term number in. Okay? So this is just an example one for you up here to study on your own. Let's go down and practice this one, number 7 here. Use the first term and the common difference to write the rule for each arithmetic sequence. So number 7. You know what? Let's write our formula right here. A sub n, you drop the n, subscript, A sub n equals A sub 1, you subscript the 1, plus, in parentheses, n minus 1, and that is going to get multiplied by the d. I guess I've kind of gotten a little too close here. Okay. That's the formula. When we have to write the rule, we're going to replace the first term, the A sub 1, and we're going to replace the d. So they tell us in this one what the A sub 1 is, and they tell us what the d is. So we're ready to write our rule. A sub n equals, what are we going to put in place of A sub 1? What are we going to put in place of A sub 1? Oh, right here. 10. The first term of this sequence, we don't even see any part of the sequence. They're just telling us some stuff about it. It starts with 10. And what does it go up or down by? By what? 4, right? Yeah. So it's going, so what we're going to do is the only thing we're going to replace right now is we're going to replace the A sub 1. We're going to say here's what it starts with. And here's, we're going to put that 4 in parentheses. And here's what it goes up by. It goes up by 4s. There's the rule. So now, if I give everybody in here a different term number to find of this sequence, you could all use this rule to get it. So if I said to Andrea, you're going to find the second, Maisie, you're going to find the third, Seth, you're going to find the fourth, using the rule, all the way around, we would be able to start this sequence out. And then I would get to Blake and I'd be like, well, you know what, Blake? You're going to find the 200th term for us. And you might want to use this rule to do it, so it doesn't take you so long, because I'm not going to wait for you. Okay? So, this is the rule that would help us find any term number of that particular sequence. We right now know it starts with 10, it goes up by 4s. What would be the next term of this sequence? It starts at 10, it goes up by 4s, 14. Next term would be 18. So they're not asking us to find them, but I just want you to make a connection here to what we're actually working with. Okay, number 8. They give us this sequence, -5, 0, 5, 10. We have to be able to write the rule for it. We got to be able to identify what's the first term. What is the first term of this one? -5. So our A sub 1 is -5. So let's put a box around that. Our A sub 1 is -5. And what's the common difference? In other words, to get from one term to the next, what do you do every time? You add 5. So it's a positive 5, isn't it? So we have D equals 5. Now we're ready to write our rule. Go ahead, write the rule for this one. Write the rule on that line for this arithmetic sequence. The rule that would find any term you're asked to find. Seth, I need you to sit up, please. Sit up, please. That would mean your head's off the table. Thank you. And do what I'm asking everybody to do. I'm asking you to at least try. Okay, anybody think they got it for us?
Does it like start out like
A sub n is how it starts, okay? It starts A sub n. Okay, Adam?
A of n.
A sub n.
Okay, yeah.
We're going to learn how to talk.
Equals
Right, that's all.
-5
-5.
plus, and then parentheses, n minus 1, parentheses, 5, parentheses.
Okay, that's the right rule. We replace the first term in our formula. We replace the common difference part of the formula, and this now says no matter what. Notice the the only thing left in it are n's. Before we had not only n's, but we had that a sub 1, and then we had a d at the end. So now the only thing we see are n's. Once we know what term number we're going to have to find, we'll replace those n's with that term number. Okay, so that's just practicing writing the rule. So when they ask you to write the rule, that's what they're asking you to do. Anybody have any questions? Okay, then let's go do some finding the indicated term, the given term. Okay, so here's in number 9. What did they give us right here? What is this called? This is our rule. They already gave us the rule, didn't they? They want us to use this rule to find the 32nd term. Before we do that, could anybody tell me right now then, what does this arithmetic sequence start with? What does it start with? No, what does the arithmetic sequence start with? 6. Because our a sub 1 value, I want you to write that down, our a sub 1 value is 6. This arithmetic sequence starts with 6. And then it tells us that our d value is 3, right? That's at the end. So just for the fun of it right now, I want you to give me the first 3 terms of this sequence. What are the first 3 terms of this sequence? Preston? 6, 9, 12. We already know the first 3 terms. But we don't want to have to keep doing what? What were you doing to get those, Preston? You're just adding 3, yeah. You just keep adding 3. But we don't want to have to do that until we get to the 32nd one. We're going to use our rule. So let's write our rule right here. We're going to put a sub what? What term are we looking for? 32nd term. Yep, the 32nd term equals 6 plus 32 is going in for the n in parentheses. And we have times that 3, our common difference. So what I want you to do is I want you first to leave that 6 as 6. Just do the subtraction part first. What's 32 take away 1? 30? 31. So we're following order of operations. Do what's inside parentheses first. Next, do we add or do we multiply next? We multiply next. So 6 plus, what's 31 times 3? 93. And so we are, I think, to our last step, so I'm now going to bring down my a sub 32. I'm going to say that the 32nd term of this sequence is what? 99. Yeah, 99. But I never want you to be satisfied to just have an answer. That's why I had us write the first 3 terms of the sequence so that we could see what's happening here. Is it growing or getting smaller? What's happening here? Is it getting bigger as we go along or getting smaller? Getting bigger. So we would expect the 32nd term to be something a fair amount bigger than 12, right? And is it? 99? Do we feel happy? Feel a little bit content with our answer that at least it's a positive 99? Okay, I want you to do this part for me right now for number 10. I want you to do this part right here. I want you to identify the first term of the sequence. I want you to figure out the d value. And then I want you to, you don't have to write the first 3 terms of the sequence. Instead, this time I want you to write the n value. Okay, so a sub 1 equals, d equals, n equals. This time they gave us the first 4 terms of the sequence. Maisie, what'd you put for A sub 1? Negative 8. Sydney, what'd you put for D? 2. Is it a positive 2? Okay. Talia, what'd you put for N? 100. There we go. Okay. We have all the information we need now. We need the first term. We need to know what the common difference is. We need to know what term number we're looking for. So now we're going to write our formula down that goes like this. A sub n equals A sub 1 plus n minus 1 times D. That's our formula. Get that memorized. A sub n is the term I'm looking for. A sub 1 is the first term. N minus 1, that's when I'm taking the term number and subtracting 1 from it because I've already taken care of the first term. And then I'm going to multiply by the common difference. So A sub what? This is our substitution step. You got to show this. A sub what? 100 equals. What's substituting in for A sub 1? Negative 8. What's substituting in for N? 100. What's substituting in for D? 2. Before we actually let our calculator help us out here, I want you to tell me, what do you expect the 100th term to be, positive or negative? Positive, because it's moving in all of the first terms are negative, but at least it's moving in the positive direction, right? And it's only going up by 2 at a time. So do you expect it to be something like 3,000 something? Probably not, no. So let's show the rest of our work then. Negative 8 plus, what's 100 take away 1? 99. Next step would be to multiply that 99 times that 2. What is 99 times 2? 198. Looks like my smart board here has chicken pox or something. Okay. So our 100th term is 190. Seem like a reasonable answer?
Yeah.
Yeah. Okay. So we always want to ask ourselves that question. Does our answer seem reasonable? Okay. So this is what you'll be doing in these problems at home tomorrow. You use the formula, use the shortcut, save yourself, a whole bunch of paper and lead. Anybody have any last concerns before we start on homework? Okay, then I'm going to let you go to work.